So what I'm going to talk to you is what I'm going to give to you is some basic ideas about life cycle assessment, which is becoming more and more popular in many sectors, including the agri-food sectors and in aquaculture. What is LCA? It is a tool that allows one to quantify the environmental performance of products, processes, services. And the important point is that the LCA takes into account the complete life cycle. Of course, we will see that the analyst has some margin in selecting what we are going to call the system boundaries, but typically the life cycle assessment includes also the final stages of the disposal of a product, and the results may be different if you take into account different way of disposing your products. And starting, of course, from the raw materials that were used to produce your service products. This is why in the framework of circular economy, life cycle assessment is really important, because if you think about what we saw yesterday, if you reuse a product, typically you have to inject in your system more free energy, exergy, but you save raw materials. And it's not easy at first sight to understand if in the end there will be a real, let's say environmental benefit out of that. The methodology was developed starting, let's say, about 50 years ago, and became a kind of comprehensive environmental burden analysis in the 1970s. It was introduced, sorry, there is a mistake, and boomed in the 1980s and 1990s, in particular for analyzing manufacturing processes, industrial processes. It was standardized in the early, in the past decade, and then the standard was updated through the years. That's important because since it is a standardized methodology, if it is carried out in a transparent way, it means that the results can be shared and the results obtained by different analysts can be compared. LCA allows for standardized environmental certification based on ISO 14021. It is used to track, monitor, and then take action in, for example, mitigation action for mitigating environmental impacts in production processes within many economic sectors, and its use in the agri-food sector is increasing. I believe you heard about, for example, carbon footprint, which is one of the most talked about environment that technically called impact categories. You can estimate ecological impacts on ecological systems, on human health, of course, and different ways of dealing with waste management. It is used by an increasing number of companies for different purposes, not only to enhance the environmental sustainability of their production and commercialization and disposal strategies, but also for communicate their achievements in the area of sustainability. This is becoming more and more important. Now you can probably, I mean, for sure you heard ads in which the companies are claiming that they are producing a certain item with zero impact on the environment, with zero CO2 emissions or things like that. All these results, in principle, should be obtained through a quantitative methodologies such as life cycle assessment. Very important also the fact that LCA is included in the Environmental Product Declaration as a methodology, and which, of course, means that any company who would like to use this label has to carry out an LCA concerning the product they want to label. So life cycle assessment has expanded, let's say, into other area. And now people are talking about life cycle thinking as a way of organizing the whole production process. I took in these slides in which you can see the idea of developing the different typology of assessment in the kind of life cycle management approach that more and more companies are in fact implementing. Using a life cycle management approach, you can start designing a new product. In GAIN, we did not focus in particular on what happens after fish is harvested. But if you think about the variety of fish and shellfish-based product that you can find now on a supermarket shelf, you can imagine that this is just the start of a story, which then brings you the fish processed in different ways to your table. So we have to think also about that, about companies which then transform or the fish in a product that ends up on your plate, since therefore you could design a new product taking into account the different area of sustainability. And you can see here that besides life cycle assessment, which is the starting point, other methodologies were deployed. Life cycle costing, which is now I think an hot topic in economic, and also, and this is, let's say, less standardized as far as I know, the social life cycle assessment. Putting together these methodologies, you can then design some operational tools to improve the sustainability of your products, process, service. And if you are designing a new product, of course, based on a preliminary analysis, you can also come up and draft a business plan. So, which are the main LCA application? Of course, we can try to use this methodology to improve our products or our process, identifying what are called environmental hotspots. In a production process, as we are going to, we will see, where looking at the example that I will show you, which is taken from a paper that I will make available to everybody as a reading. There could be different stages, and some of these stages can be more impacted than other one, and therefore you can focus on those trying to reduce your environmental impact. And this is called also, this is kind of information can be delivered also from an analysis of the contribution of the life cycle stages to the overall environmental load. A very important objective of life cycle assessment is also the comparison between products. This can be very useful information for consumers. Now, I'm sure you saw some reports or documentaries in which, for example, the impact of different food items is compared in terms, for example, of carbon footprint, of water footprint, or other type of impact categories which are, let's say, easy to understand for a consumer. And of course, this can orient the choice of consumers. If I need to get a certain daily ratio of protein, I can decide to get it from fish, from meat, from vegetables, some vegetables. And of course, this I can decide, I can take this decision based on my taste, but also taking into account the impact of my choice on the environment. This comparison between products and processes, of course, can also lead one to select the most environmentally friendly one, and then this could be could give a premium price, in particular if you are targeting a market, a sector of consumers who are particularly sensitive to the decrease or the increase in the sustainability, and therefore the decrease of our impact on the environment. It's also important for standardizing metrics and identify key performance indicators that can be used then for what I call the life cycle management. Why should we bother about LCA? Well, if you want to get a more comprehensive view of what's happening in the field of aquaculture, I can recommend you to read a couple of nice reviews, quite recent, in which you will see that the number of papers and analysis focus on aquaculture is rapidly increasing. It's rapidly increasing for the reason that we already explained. It can be of advantage to the industry to use this tool to show that their way of producing is more sustainable, and to support this claim with some quantitative numbers that can be easily communicated to customers and consumers. So how does the methodology work? Typically, it works, it is organized in 4 phases. These phases were also codified and by the ISO standard, which describe the principle, the framework for life cycle assessment. The first stage is the definition of the goal and scope. The second one, it's probably the most time-consuming one. It is called the inventory phase, because one has to collect all the data concerning flows of matter and energy which are used to produce a given product, but also to dispose what is left at the end of the life of your product. The third phase is an analytical phase in which the data that were the flows which were invented are then converted into what we are going to call the impact categories, and for example the famous carbon footprint, but there are other ones that we are going to briefly mention in this lecture. And then the fourth phase is the interpretation. In the interpretation stage, you try to learn lessons from the impact assessment to identify the hotspots, and then to try to come up with some actions to reduce, of course, the overall environmental impact. Okay, I would like to underline, and of course, as any methodology, LCA has some limitation. The first thing that is important to understand is that even a relatively simple production process includes many variables. And in fact, when you are trying to represent this process, at a certain point, you will have to make some assumption, either because you are not able to collect all the necessary data, or because if, let's say, you would consider all this data, the calculation could be too cumbersome. So in the end, when you are applying life cycle assessment, you are to some extent modeling, trying to extract which are the essential feature of the product, service, or service that you want to analyze. in such a way that then the model can be fed with the data that you are able to collect. So the results will always refer to something which is slightly less complex than the real process. Of course, the challenge is to develop the model in such a way that the main feature of the real process are captured. The first stage is the goal and scope. So in order, it seems trivial, but sometimes it is not. And if you do not define well what is the goal and the scope of your analysis, then you may, in fact, waste time in carrying out the rest of the other three phases. So you need to have a very precise idea of the product, process, or services you want to focus on. You need to define the functional unit. This is very important, in particular for comparing products. We will give you an example of that just after this slide. And the description, you have to describe what are called the system boundaries. Life cycle assessment is based on the idea, on the concept of system that was illustrated also in the second day when we're talking about precision aquaculture. The system is like a box, and you need to understand what goes in the box and what comes out of the box in terms of flows and energy and matter. And therefore, based on that, you need to evaluate the requirements, the data that you may be able to collect, and based on that, also made some assumptions. The important thing, in particular, if you want to come up with a report, for example, if you are a company and you would like to analyze your own processes, then you would like to communicate the results. Of course, the intended audience should be taken into account. I think that we already covered this. So let's try to understand more concretely how these phases can be implemented following an example that then you can follow in detail in the paper that we published a while ago with Silvia. So of course, when you are trying to define the goal, you should have in mind which are the impacts that can be potentially caused. The goal should be clearly stated and should reflect the function of the product. The functional unit, for example, that we selected for our paper was 1 ton of live weight trout at the farm gate. This could be an example of a functional unit if, of course, you define the production process as a process that ends at the farm gate. You don't consider what can happen afterwards. So the paper I was talking to you about is this one. And now we are going to have a look at how we proceeded to implement the life cycle assessment for this case study. We took into account the production of rainbow trout in the northern eastern area of Italy, in Trentino Alto Adige. We wanted to identify environmentally relevant hotspot of the supply chain. We introduced in the analysis, as you're going to see, also the processing of trout up to the reuse of byproducts of this processing as pet food. As a functional unit, we consider 1 ton of live weight trout. So the inventory, as I told you, was definitely the most time-consuming step. Going back to the question that was asked to Cornelia, we had to get in touch with different fish farms of the area, trying to involve them in the analysis because we needed to get data about the flows of metal and energy involved in the production of rainbow trout. We were supported by a consortium, the Astro Consortium, which gathered together, I wouldn't say all, but most of producer in Trentino Alto Adige, and very kindly gave us some contacts and some possibility to get in touch with farmers, and also provided us a lot of data concerning the processing of trout after harvest, as you can see here. So we took into account we consider the whole supply chain, from the production of fingerlings to the grow out stage to the processing of the trout, which is different according to the size at which the fish is harvested. This is just a pictorial, let's say, view of the type of data that we collected. We collected data about different input that, since you're all familiar with aquaculture, know very well. Fish feed, the infrastructure that are needed to run a farm, the additives that are required, energy and water consumption. These are just a few examples that the details can be found in the paper of the main item. Of course, when you take into account the impact of infrastructure, you have to take into account their lifetime, because you have to, let's say, distribute their impact through the lifetime of these infrastructures. And the output for us was fish that can be marketed. That biomass, we saw that disposing that fish has a cost, potentially, or maybe in the future with the waster machine can also be a source of income, of small income. And of course, the discharge of wastewater, because in this case, in the Trentino, most farms, I would say all farms, are raceway farms, which discharge non-treated water back to the river. So, of course, from the picture, you have to then go to the next stage, which is the collection of all data, and therefore to a kind of mass balance, in which you take into account whatever goes, mass and energy balance, in which you take into account whatever goes in your system and what comes out. So in our paper, we wanted to analyze what happens starting from the production of the fish up to also the reuse of byproducts by, in this case, another company which processes byproducts to produce pet food. So here you can see the main inputs aggregated in different, let's say, categories: consumable goods, transportation of these goods, energy and water use, and capital goods, infrastructure and equipment. For all of these phases, we had to collect data concerning these 4 categories. And for example, and out of that, we tried to understand a kind of mass balance, which led us to the production of our functional unit, which is 1 ton of trout for human consumption. So Based on the data that were provided by the farmers, you can see that you need approximately 2.2 tons of aquafeed to get, during the fish grow-out phase, 1.8 ton of trout live weight. Then this is processed, and you can get 1 ton of food for human consumption and nearly 0.9 ton of byproducts then that are then channeled to another company to produce the pet food. Sorry. Along with the input, you have to take into account the impact of the outputs. Of course, fish metabolism produces some residuals, and you have also some residuals of the production of pet food. This is an example, for example, this is an example of an inventory, which, of course, since we choose these functional units, are scaled to 1 ton. As you can see, the data are aggregated within the different categories that I showed you. As a consumable, you have the fish, the ingredients in fish feed, other animal ingredients in the feed, plant ingredients, because we look at the composition of the feed based on the data that were provided to us by the consortium, which buys the food for all the farmers. And we were able then to quantify what is required to produce our functional unit. And then we added also the other input which are required for feed production. So in the next stage, once we have collected all the data, we put this data into the, let's say, a machinery, into a software, and this will be described to you this afternoon in more detail, to convert, let's say, all these flows in effects on the natural environment. And these effects are named impact categories. Without getting into much detail, I just would like to show you some of these impact categories. Some of them are also quite widely or frequently used in aquaculture, and we stick to them in our paper. For example, the global warming potential, which is often let's say, referred to as a carbon footprint, which is measured in kilogram equivalent of CO2, but of course is caused also by the emission of all greenhouse gases, which are converted in CO2 equivalent using conversion factors given by the IPCC. Other wide categories in aquaculture, the terrestrial acidification, which is measured in kilogram of SO2, eutrophication, which can be related to freshwater and marine water, and is then measured in phosphorus of nitrogen equivalent, because it is believed that these two are the limiting nutrients in these two environments. Terrestrial ecotoxicity and freshwater ecotoxicity, which were standardized on the toxicity of these particular chemical compounds. What I would like to remark is that this impact category comes from the inventory of all the inputs that you saw previously. And for example, in case of the eutrophication, does not refer to the actual eutrophication caused by the emission of wastewater in the surrounding of the farm, but usually the results of an LCA refer to a generic eutrophication potential, not linked exactly to the local direct effect of your farm, which has to be assessed using different methodologies. Another impact categories, which is very important, the cumulative exergy demand. Exergy can be a rather a little bit obscure concept, but let's say that it is a way of summing up together different forms of energy which have different qualities. For example, heat and electricity, they have different quality. You can then weight, let's say, them in a different way and come up with a single indicator, which is called exergy. Okay, I think that the idea of impacts was already covered, so we can go on trying to have a look at what happens in our system once we have introduced the data and calculated the impact category. Of course, there are different methodologies for calculating the same impact category, and this makes the comparison between the results of different studies a little bit tricky. Here you can see, for example, some of the most commonly used methodologies. Of course, as I told you, LCA began coming into practice and being more and more commonly used in early 2000s, also in the agri-food sector. And as the time goes by, researchers try to introduce new methodology and more efficient methodology. So as you can see here, for example, if you wanted to calculate an impact category, for example, let's say climate change, so global warming potential, you have a very wide choice of methodology, and the choice of methodology in the end can affect your results. Through practice, anyway, in different fields, different researchers, let's say, oriented the use and the standardization of methodology in such a way that then the results became more and more comparable. In our paper, for example, we estimated the assessment using one of these methodologies, one of the most recent one, which is called RACP. And we selected these categories that you can see below in the graph. So global warming potential, that, let's say, carbon footprint, to be more explicit, terrestrial acidification potential, TAP, FAP, freshwater acidification potential, TETP, which stands for FATP, sorry, which stands for freshwater ecotoxicity potential. TETP is terrestrial ecotoxicity potential. FEP, which is the eutrophication potential, and CT, which is the cumulative exergy demand. So what can we see in the results here? So, for example, if we look at the global warming potential, we see that here we have different components, and this is the life cycle impact assessment of the feed production phase. So here we have the impact due to fish meal and fish oil in feed, the impact due to the components obtained from other, let's say, protein from other animal, protein from plant, transportation, energy consumption involved in the manufacturing of food, and water consumption. Each of these items in the inventory contributes to a total of 1,700 roughly kilogram of CO2. Of course, this total is referred to our functional unit, 1 ton of aquafeed produced in this case. And then this can be scaled on our functional unit because we calculated through the mass balance how much feed is needed to produce 1 ton of trout. Which kind of other information can you get out of the output that software such as CIMA Pro or other professional software can give you? You can see here more clearly what happened in the different phases that we call feed production, fish grow out, fish processing, and byproduct processes in terms of the different impact categories. Let us take again as an example the global warming potential, therefore the kilogram of CO2 equivalent which are emitted through this process. And you can see that the feed production accounts for more or less 50% of the whole global warming potential of the whole carbon footprint. And what can you see again here? That in fact processing the byproduct requires in fact quite a lot of energy and produces some CO2 emissions, because in this case the factory which was processing and producing the pet food was using energy from the Italian electricity mix, which is still based a lot of fossil fuel. So this gives you an hint, for example, that kind of impact could be greatly reduced if there will be an ecological transition in our energy systems, and the production of pet food could be achieved using renewable form of energy, which do not emit carbon. So this is an example of what is called sometimes analysis of contribution. And so by let's say disaggregating the impact with respect to the categories that were defined, we can try to understand which is the weight of the different categories on this impact, and then of course trying to improve, trying to reduce which is the most relevant one. This is another example of the relevance in fish farming of, for example, of the impact of feed that was mentioned also yesterday. So if we would like to summarize what we found in this paper, well, it is well known that aquafeed production is one of the key environmental hotspots in aquaculture, and this is why yesterday, as Louis was saying, all companies producing feed are trying to reduce their, to improve the production of feed in terms of sustainability. But as Louis was also saying, it is also very important to improve the way in which feed is given, the way in which feed is designed, because by improving the nutritional properties, you reduce the amount of feed that is needed, and on the other hand, you reduce also the wasted feed and what is then emitted in the environment as non-digested feed. In this area, of course, LCA is also a research area, because researchers are trying to introduce new categories which are able to give a more precise idea of the impact. For example, there is a lot of research being done in the areas for introducing impact categories that can give us a better idea of the impact of emissions on biodiversity and on the appropriation of biotic resources, which of course are very challenging and very difficult to estimate. The second step, during the second step, eutrophication emerges as a key issue because of the emission with wastewater. And of course, thinking about different systems in a system such as a RAS, this issue is dealt with because you can reduce the amount of wastewater which is released in the environment, and you can also sequester nutrients from the wastewater, as we saw yesterday, and as was shown also from Cornelia in the previous talk. Okay, fish processing. It was carried out quite efficiently in the example that we looked at, because in this case there is an economy of scale, but also, let's say, an economy in the sense a saving in environmental impact, due to the fact that the producers got together, and therefore they were able to convey most of their products to a single processing unit, saving energy, for example, and saving in the end environmental impact, and also optimizing the use of fish. For example, fish which was not fit to be marked as a wool was processed and converted into hamburger or things like that. So we found that the practice introduced by Astro, this consortium, was really close to optimal. As regards the last phase, the transformation of byproducts from fish processing into pet food, as you saw, the energy use is quite high, which leads to a quite high impact in terms of global warming potential. And this is due to the fact that we are still using a lot of energy which comes from fossil fuels, can be improved in the future by changing the way in which we extract or we convert other sources of energy into electrical energy. So very briefly, since we are, I am close to the time is, since the time is running out, just would like to show you very briefly an example that could be of interest, because it runs in parallel with what you saw in the previous talk, and perhaps gives you the idea of what we did in GAIN in terms of sustainability assessment, because we look at the same process for the two angles, from the economic and the environmental point of view. So here, and we are going to submit a paper about that, which hopefully will be open access, and we can notify to you when it will be published. We took into account the new process that was described to you in detail yesterday by Christian for filtering and drying the sludge from ERAS, and compare this process with the mainstream process that is now being used. In this case, we took as a functional unit the sludge which is released for producing 1 ton of salmon smolts. So here you can see another way of representing an inventory through this kind of diagram, which are called energy diagrams. you will have the slides, and you, if you wish, you can have a look at details of the inventory yourself. You can see here the RAS farm, the different input, more or less the same that we cover in the previous example. And of course, the challenge is to put numbers on all these inputs. So let's come just briefly to the results. So we combine the sludge treatment, the innovative sludge treatment, with different scenarios of use of the products that can be generated by filtering and drying the sludge. And we compare then the results in terms of impact categories with, let's say, the mainstream scenarios, which is the RAS with no system for drying and extracting other products from sludge. So what you can see here, A is the mainstream, let's say, RAS, and the B1, B2, B3, etc. are the three RAS equipped with the innovative filtering systems. So as you can see here, you have a very marked reduction in almost all impact categories except for water consumption. For example, you have more than half emission in terms of CO2 equivalent, and therefore the introduction of this methodology could lead to a very strong, could mitigate, let's say, climate change in terms of reducing the emission of CO2. So as you saw in the previous talk, this new process has advantages from the economic point of view, but has also huge advantages from the environmental point of view. So let's say that it will be a win-win strategy for us in the future to adopt this kind of innovation. Okay. This is more or less what I already told you. Just to finish, short introduction to what you are going to listen to this afternoon. This afternoon, Silvia will guide you through some example of application of LCA, starting from a very, very simple one. And then we'll give you also some idea about how this software, which is one of the most widely used, CIMA Pro, works. Of course, LCA is to be carried out professionally. You need a lot of experience, but I think that it could be relevant for everybody to know that this tool exists and to know what the tool can do, because then this could allow you to talk to the LCA analyst and get out of an LCA analysis what you exactly need.